All right. So today we're going to look at finding the probability of something happening based on the z-score that we looked at yesterday. And this is the last day of my instruction. So after this, y'all will have some class time to work, but you don't have a lot of time because you should be kind of collecting this stuff and doing this stuff in our off time, like when you're done. Um, so this curve shows the heights of WNBA players. I'm going to kind of propose this as a more of a discussion and just some for your own thought. Take a look at any spot along the curve, um, or sorry, take a look. Any spot along the curve corresponds to the players who are that height. Okay, so like right here, that represents 72 inches, um, so on and so forth. What do you notice about how high the curve is at different heights? The taller the curve at that spot, the more players there are with that height is what we should observe. So when the curve peaks, that's where most players fall. Now, if I randomly pick a player, what do you think the shaded area to the left of 69 inches tells us about those specific players? That shaded area shows what fractions of players should be shorter than 69 inches. And that's kind of what we're going to get at today is, well, so when we talk about the fraction or part of the whole group, we call that a proportion. Now, in statistics, if we think of a randomly picking one player, that proportion can also be thought of as probability and the chance that that player is shorter than 69 inches. So the probability that a randomly chosen player falls in the shaded region is exactly the same as the proportion of players who fall there. That's why the area under the curve matters. So every time we shade part of a normal curve, we're finding a proportion of the data, which also tells us the probability of randomly selecting someone from that range. So we're going to be doing what we did yesterday, but we're going to be adding to it. And then here's an entire curve. We need to understand that if the entire curve is shaded, when we talk about proportion, this is the whole thing, right? So that would be the total area under the curve would be 100%, which tells us the area under the curve is probability, if we can say it that way. So when we talk about probability on a curve, we really have three different ways to think about where data values fall. We can look at a data value and we can say what percent or what's the probability of something happening less than or in between two values or greater than. So when we talk about probability on a curve, we're asking about the likelihood of landing to the left of a point, between 2 points, or to the right of a point. So from z-scores to probability, yesterday z-scores told us where a value is. Today's question is saying, how do we turn location into probability? Google Sheets will do the calculation while we do the thinking. So in Google Sheets, you're going to pick one of the groups. You don't have to do all three, just one of the groups. If you're a boy, probably choose boy, girl, girl. And I would just probably do something like that. But this is kind of your final component. This will also be done on a sheet of paper. Um, and I want you to write in your notes the group that you chose. So there's a spot that says group in your notes. So write the group that you choose and then fill in the information. You're going to start by sketching and labeling the normal distribution curve for that group, showing the mean, 3 standard deviations above and below, and then you're going to label where your height fits on the curve, either with a dashed line, probably a dashed line, along with the data value. So for instance, for me, I'm going to start off by saying I'm going to choose boys, and then I think I show all of these, even though you only have to choose. Oh no, I'm choosing the group of boys. Yeah, but I'm doing all three. So once again, my mean and standard deviation is different than yours, more than likely. If you're using boys or girls, it's definitely going to be different. So I'm choosing the group of boys based off of my data from last year, where the mean was 70.1 and the standard deviation was 3.2. And I'm going to go through and I'm going to label, like all of these should look the same at the bottom, like the mean with 3.2 standard deviation. That should look the same. And then I'm going to go through and put my data value. Like my height's 71 inches, so it should be the same. I'm going to also use my wife's height. but I'm only going to use that in the middle one. So I'm going to put 71 inches is kind of close to there, right? If the mean is 70.1 and one standard deviation 73.3, then that's about where 71 inches would be with respect to the population, to the area under the curve. So on the middle one, I'm going to put my height along with my wife's height, but I'm going to put my height. I try to put it in the same place every time. Then I'm gonna put my wife's height right here. Now she's also in a group, and this is talking about guys' heights. So we can also clearly see that she's, in terms of, like, she's not a guy, but in terms of guys, she's obviously less than average, almost 2 standard deviations less. So, all right. Let's see. So those there, I have those labeled. Now we're going to look at shading areas. So shade the areas as specified below. What are we looking for? We want the area to the left, so the percent shorter than you. That would be this area. Okay, which, if we look at this real quick, before we do any calculations, if remember what I said about the entire curve, that represents 100%. Well, I have half of this curve completely shaded, right? And just a little overlapping over 70.1. So I would expect that my shaded area is somewhere just a little bit above 50%. Like, I would say that a little bit above 50%. We're going to find out more in a second when we run this calculation. But I would expect, in other words, if I got 76% when I calculate this, or 23%, that's wrong. Like, if I got 53%, 53.4%, I would say I'm pretty confident with that. Okay. Looking like that in the middle, we were looking here. Here it may not be as obvious. I would expect somewhere about, maybe, I know that this area, when we talked about the empirical rule between 1 and 2 standard deviations, this is 64% between here and here. So if I look at just half of that, which it's even overlapping a little bit, that's 32%. And then we have this area. So I'm probably looking like under 50% here, but maybe close to 50. And then over here for this side, once again, if the right side of this is 50%, the left side is 50%. Sorry, I said that backwards. The left side is 50%. The right side is 50%. This is almost the entire right side, but we have this gap here. So I'm expecting this to be less than 50%, but most of them to be probably close. And that could vary depending on, your specific data value that you have. I just happen to be, I'm doing guys' heights, and I'm close to average in that respect. So, anyways. All right, so here's what we're going to do. We're going to open our Google Sheets, and we're going to add the following to your group you selected. So I'm not going to pull up my Google Sheet, but yours should look like this. This is your kind of your everything that you should have that we've have built on there. So yesterday we did Z-score. Now we're going to add partner's height. We're going to write percent shorter than me, percent between us, and percent taller than me. And then I'm going to put my histogram at the bottom of all of that. Then we're going to open our Google Sheets and add the following to the group you selected. So here, X is considered, I don't even have the formula up yet, do I? Okay, I'm going to give you a formula here in a second. X is your height, upper and lower are you and your partner's height, and SD is the standard deviation of that group. So I'm telling you this because that's part of our formula that we're going to use to figure out these probabilities. You'll compare your own height to one of these groups. After that, you'll find out the probability. So the chance of randomly choosing, not randomly chosen person from the group being shorter than you, I guess it could be. The chance of randomly choosing a person from the group of your height falls between you and your partner, and taller than you. Okay, so let's look at this one first. So we're going to find these probabilities. So to find the probabilities, let's look at the area to the left first. This is the way that the formula looks. So it's a norm dist function. So equals normal distribution. And so we have to spell this right, equals NORMDIST. Then we're going to do parentheses, and this is broken down. We need 4 values here. The first value needs to be your height, comma. We're not doing any spaces, just your height, comma, the mean, comma, the standard deviation, comma, in the word true. So on my example, I'm not typing in numbers. I already have things in my cells. So in my example, this is what mine looked like. Equals normal dist. That says I-19. That is where I put my height. I-3 was where I put my mean. I-18 was where my standard deviation was calculated, and then the word true. When I hit enter, I want to format this cell as a percent, by the way, and I want to round it probably to the nearest 10th place. Decrease decimals to only show 1 decimal place to the right, unless there's a number zero there. Like, I don't care about 72.0%. You can just make that 72%. And so whatever I got, that's what I would type in. The formulas are going to be slightly different depending on the areas that we're shading. When we're shading in between, we have these upper bounds and lower bounds. Here, I'm taller than my wife, so my height is above her. So I would say that's upper bound. My wife would be the lower bound thing. So that's where this kind of comes in. We have to do this kind of twice, and we're taking the difference of those to find the area in between two things. So the first thing that we write is going to be the same thing that we just did, because I'm taller than my wife. If my wife was taller than me, then one thing would change, and that would be her data value would be right here where it said upper. But since I'm taller than her, that's the larger number. I'm going to do equal norm dist. The upper is going to be my height, comma, the mean, comma, standard deviation, comma, true. And then I'm going to close my parentheses. I really haven't had to do that, but I have another function here. I'm going to close my parentheses, and now I'm going to subtract the same thing minus normal distribution, and then with her height for the lower, because it's a smaller number, the same mean, same standard deviation, and the same word true. Okay. And this is what mine looks like with that I have plugged into my formula. Lastly, we're going to do to the right. And the reason why we have to do all this stuff is, and there's actually, this can get kind of tricky. Your calculators actually can have an easier way to do this, but we're not doing this in our calculators. But we have to, the probability that we get only gives us the area to the left of the curve. So we have to kind of manipulate it a little bit to figure out the area in between and above. So with that in mind, to find the area to the right, we do the same exact thing, except we do 1 minus the normal distribution. And this is not between, so I'm just concerned with my own height. Okay, so my height. So 1 minus the normal distribution of my height, which is the upper one, mean, standard deviation, and true. Plug it all into that cell would be this. And so we can go through and see my actual percentages after I calculated them. So here, I said I would expect this number to be close to 50, right, for the left, but like not really abstract. 61.4 is fine. I guess my intuition was a little bit off. 58.7 in the middle, and then 38.6 taller than me. So if I pick someone at random, this is kind of the prompt that I want you to use when you're going through interpreting your probability to kind of conclude your project, is just take something like this and fill it in. So in your notes, you need to be filling in the numbers that you have. So if I pick someone at random, there is a 61.4% chance that they are shorter than me, a 58.7% chance that their height is between mine and my partner's, and a 38.6% chance that they are taller than me. Please do not just get in the habit of copying my stuff, because yours will not do heights. So yours should not say chances that they are taller or shorter or anything like that. Like, you need to interpret this with what your actual problems are. So now you guys need to take your, I don't know if there's, I think there's Delta Math over this part. Yeah, there is. So now finally we need a copy, since we're done with the spreadsheet, we need to copy the whole thing for our final practice sheet so you can finish your delta math and it doesn't take you that long. And then we're going to conclude with a couple other problems that we're going to use as our practice sheet involving the WNBA player again. This is just to get kind of a little more of an example. So we're going to find the proportion of a given value on a normal distribution for a WNBA player that are shorter than 69 inches. So I already have this labeled for us. We're going to go ahead and mark where 69 inches is. That would be right here. And I'm going to always shade that area. That's a relatively small area. I'm doing that so I can shade and like make sure my answers are honest, right? So I should expect a small percent because I have a small area shaded for that. So less than my the mean and standard deviation are 2. If I plug these in to 2 decimal places, I think I told you I'll do 1. Yours would say 6.7. Oh my gosh, or 6.68. So I'm just going to kind of run through and check these. I'm not going to go through and or you can run through and check these. I would give you all a second in class to plug in these into your practice sheet that you made. And you don't have to make the formula for standard deviation or mean or your height. Just this is a practice sheet, just trying to get those calculations. So approximate players of WNBA players taller than 76 inches. Here's 76 inches. That shaded area represents a very small proportion of that happening. So I'm going to take my mean, my standard deviation, my data value of 76, and then this is going to be my 1 minus the normal dist because it's greater than. Now let's look at roughly what percent of WNBA players are between 67 and 75 inches tall. Well, the upper bound is 75, so we're going to do the normal dist, and we're looking at this area right here. Okay, not the tail ends in between. So this is where we do this one minus this one. So we're going to have the same mean and same standard deviation. The only difference is on the first group, we're going to have 75 as our first value. On the second group, we're going to have 67 as our first value. And then make sure you put true at the end. And we should get about 92.7%, which looks like a pretty good, like we're saying, this is how much is shaded of this curve. Okay, so this is not in your notes, but I'm just gonna go back to this Jordan example because we talked about this the other day. But now I'm going to say, what is the proportion of the price of a pair of Jordans that cost $247 if the mean price is $279 and a standard deviation of 16? This is just kind of put everything in perspective. So interpret the meaning of what that is. So if I were to go through and I were to shade, what is the proportion of the price of Jordans that cost of the area shaded? This is basically saying, what's the chance of you finding a pair of Jordans that are less than $247? Okay, with respect to the Jordans that are like this particular shoe or whatever. I've already found that, like it's 2.3. You can plug that in. But how would we interpret that? You can say only 2.3% of Jordans sold are at or below the price of $247. In other words, that's a really good deal. Or you can say 97.7% of all Jordans sold are at or above the price of $247. Either way you look at it, it's fine. Also, this is, I think, the final one. This is also not in your notes, but just to kind of show the same thing. This is adding something to that. So this is determining the probability of something and then adding to that. So if IQ scores are normally distributed with a mean of 100 and a standard deviation of 15, out of a randomly selected 1,450 people from the population, how many of them would have an IQ between 106 and 125? So what we're going to do is we're going to figure out the probability of having an IQ between this, and then we're going to say use that probability just like we did in our probability project where I said, okay, now that 500 people play your game, y'all did 500 times the probability to figure out how many of those 500 people would actually win the prize. This is a similar type of thing, but we need to figure out the probability first. So I'm going to go ahead and label this, and I'm shading in between. So I want this area. So I want to know the probability of fitting in this area right here, having an IQ between 106 and 125. I would do my upper and lower bounds. And this would be my subtraction one that I use. I'm going to use 125 as upper, 106 for lower, my mean and standard deviation. Anyways, this is the way that we did it last year, not using Google Sheets. But here's our, we should get about 29.7%. And so I would take that number if it's 29.7%, and to figure out what I'm trying to figure out what 29.7% is of 1,450 people to tell me how many people out of the 1,450 people would I expect to have this IQ. So I'm going to multiply those results together, and I would get about 430 people out of the 1,450 people. Now, this, once again, this is last year's example when we did this different way a little bit, but it doesn't change the fact that we're going to plug equal norm dist 125 comma 100 comma 15 comma true minus norm dist parentheses 106 comma 100 comma 1 comma 15 comma true. Hit enter. That will give you 29.67879726, and then you would multiply that by 1450, and then you would get 430. So our difference is real. Going back to the original question, we have been investigating every day this unit. Are boys taller than girls? What do we think? Have we gathered enough evidence, analyzed the data, and interpreted the results? And how do we know that the differences we observe from our data isn't just random chance? Analyzing whether differences are significant. Just like we use the chi-square test to do the same thing with categorical data, we're going to use a t-test, which is a tool that helps us figure out if the differences we see between two groups is likely real or just happened by chance. Why we use it: when you compare two groups like boys versus girls, you want to know, is the difference in the averages big enough to be meaningful, or could it just be a random variation? So analyzing the difference, how do I interpret it? If the t-test says yes, the differences is significant, then we can be confident that one group really is taller, or whatever you measured, than the other. If it says no, then the differences might be due to luck or chance in our sample. So what you're going to do is you're going to copy the boys and girls data from your Google Sheet into the t-test template, run the test, look at the result, and answer this question: is there a significant difference between the two groups? And explain what that means in your own words. So let me show y'all that real quick. All right, so here's what the template looks like. Hopefully I remember to take this off whenever I'm done. I'm going to go over here to boys, and just like with the categorical data, we just kind of copy these over. I'm going to go down here, select and drag, and I'm going to copy and paste. So we have two columns for one variable, one for the other. So I have those in here like this. I'm going to go back to the other one and do the same thing for the girls. And I don't really care about any of the other stuff. I mean, I should be able to see, because there's already, I will tell you, there is, like, you can check your standard deviation and your mean here. We're looking at our table. So we've got the mean of the boys, the standard deviation of the boys. We also have the sample size, like how many do we have here? Same thing over here. You don't need to worry about this. We're not going to talk about that. But either way, this works the same way. So, like, is the p-value less than 5%, or is it greater than 5%? Here, it's less than 5%. So we would say that the chance that the difference in averages happen just by random chance is less than 5%. Because this chance is so small, we believe that the difference is real and not random, meaning that the average of boys is different from the average of girls. Based on our data, there's evidence that the two groups do not have the same average for heights. And we should expect that, right? If you end up with something where it's greater than 5%, you would say the other one down here. And that's something that I want you to be including on your actual project. So let's conclude with this. And that's basically kind of the last thing. But you can see rubric for specifics, but you're going to start by asking a question involving two groups, which you should have already done. Collect quantitative data, which you should have already done. Organize data into a Google Sheet, which you should have already done. Calculate mean, median, range, IQR, 5-number summary, standard deviation, z-scores, probability, which you should be in the process of doing. Creating a normal distribution poster with the mean and standard deviations labeled, as well as your personal data value labeled. Everything that we've done so far with this heights example. Calculate two different probabilities from one of your groups to compare to. So you can do the less than, the greater than, or in between is what I'm talking about with that. Use the t-test to support your conclusion and explain in your own words. That's what we just got done doing. And then that is your project. So you need to make sure that you use your slides in Canva or Google Slides, submit those into the Canva submission box, uncheck the box that sends me an email because I don't want an email, and make sure you share that with me so I can open it. And then you're going to get a poster and actually sketch out your poster. And make sure you follow the rubric because there's directions on that as well.